In this series on this podcast on an intro to vector analysis, we will talk about vector overlay functions. So, overlay, as the name implies, is just about overlaying different types, and so you've got a variety of combinations, possible combinations based off of our point, line, and polygon inputs. And so here is one where we could overlay points with lines, and the output of such an operation is points. Similarly, if we overlay points with polygons, the output is polygons. Notice how the attributes of these two are getting combined, right? And so it's 1, 2, 3, ABC, and so this becomes 1. There's no overlay of the stream, so that's blank. This one's on the stream, so 2B. This one's not, so 3. These are contained within A and B, so it's 1A, 2A, and 3B. You could have lines that are overlaid with other lines. You could have lines that are overlaid with polygons, or polygons that are overlaid with other polygons. And so the output is always the simpler of the two data types if it's a mixed input. So some special cases of polygon overlays that we've already mentioned in passing. Clips, intersections, and unions. And so what a clip does, if you have the layers that you want to clip here in the middle, the data layer, and then you have a bounding layer. So the bounding layer, we always use polygons with clips, and so it clips that down. And so to just the stuff that's within inside those bounding layers. An intersection looks for the intersection of two data sets, whereas the union looks for the union of two data sets, and this is what these look like. So all these overlay functions are available in Arc Toolbox, and so you go into either Analysis Tools overlay or into the Coverage Tools, and you'll see that there's union and intersect, like we've talked about. Clip is actually an extract. Then there's erase and some other functions that are quite useful. So let's just go through a few examples here. So if we have a vector overlay of A, the orange, and B, the green hollow, in this example you get with just 2 polygons as an input. They're overlaid and they can form a total of 9 new polygons, right? And so you've got this guy, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and so most overlay operations differ in 2 respects. So which of these polygons, these 9 possible polygons, are kept versus which are discarded, and then how do you handle the attributes? What do you do with them? How do you combine them? And so if we did a clip operation, a clip would keep both of the features, for example, of the input A that fall within B. An intersect would just keep the overlapping areas and retain the attributes from both. So they're slightly different. So here's the clip command. We've already used this. And so you could clip A with B. You can have an intersect command, and then there's the erase, where basically when you give it the erase feature, what it does is it gets rid of any information within that area. Unions, quite simple as well. So you give it 2 objects and then it creates the union of it. It does retain the geometry, and if you want to just simplify this into a blob, you would follow that up with the dissolve function. And so some of the problems with doing field overlays, any 2 such layers, there's going to be boundaries that are sometimes common to both layers, and so how it handles those is important. And then you can also have, especially when dealing with lots of polygons, you can get lots of little slivers. And those can be problematic, and how you get rid of those. So for example here, maybe this polyline is one representation of a river on the state boundary, and then I've got this simpler line here which is supposed to represent the state boundary or the river, and I would bring these two together. I can get lots of little slivers of information, even though zoomed out they look like they're the same, but actually up close they're quite different. So that's a very basic introduction into vector analyses, and what we've covered are some nuances in the different types of spatial analyses, whether they're local, neighborhood, or global operations. We've talked about selection and queries as an extremely powerful form of vector analysis. Classification, which up until now you've probably only thought of as a basic visualization tool in GIS. It's also actually a really powerful spatial analysis. And we've talked about these proximity functions and buffering functions, so things like near and buffer. And Euclidean distance, those are all really powerful, and vector overlay functions. So if you want, I'm not going to actually post this as a reading assignment, but if you want to follow up on anything, Chapter 9 in your book is a great sort of overview of a lot of the stuff we've just covered today, and really using these tools in ArcGIS is probably the best way to reinforce these concepts, and that's precisely what we'll do in Lab 4. Lab 4 is the last lab for the GIS Fundamentals folks, and this is Lab 5. I'm skipping. Lab 4 is the last one for GIS Fundamentals. That they're going to make some data, edit it, create a campground. This is going to be your first vector analysis lab. This is Lab 5, and that won't be this week. It will be next week. I apologize. So this is going to be based off of a real situation, the Chevron oil spill that was a few years back in 2011 down near Salt Lake. And what you're going to try and do is look at, okay, who could be affected by this? And so we'll use this concept of buffering and try and find all the parcels and households that need to be notified that are along the stream that is downstream of the source of the spill. And so that will do us for this podcast on an introduction to vector analysis. Thursday's podcast, we'll start talking about analyses that combine vector and raster data. All right, have a good one.